Alright, in this video we are going to be doing the correction of the assignment I gave you 2 weeks ago, and that is for pure mathematics with statistics. Now the question reads: the marks obtained in mathematics and chemistry by 10 candidates of a certain class in an examination are given in the table below. So on the first row we have the marks obtained in mathematics, and that marks is called X. And on the second row we have the marks obtained in chemistry, and that marks is called Y. And you may assume the following sums. The sum of the mathematics marks have been given as 390, and the sum of the chemistry marks have been given as 352. Now the sum of the squares of the mathematics marks have been given as 18,924. I think there was a mistake in this value, and that gave you the value of the variance of X to be negative, which is not supposed to be so. So the actual value was actually 18,924, and the squares of the chemistry values too was given as 14,686. And finally, the sum of the product of the marks value with the chemistry values too was given as 16,344. Then the A part of the question, you were asked to calculate to 3 decimal places the product moment correlation coefficient and the Spearman's coefficient of rank correlation between the maths and the chemistry marks. Then the B part was to interpret both coefficients, indicating which one is more reliable for the purpose of interpreting data. And the C part is to find the equation of the least square regression line of mathematics marks on chemistry marks, leaving the constant to 2 decimal places. Hence, estimate the mathematics marks of a candidate who scored 34 in chemistry. Now I'm going to move on with the solution. So here we know that the formula for the product moment correlation coefficient is R, which is equals to the covariance divided by the square root of the variance of X multiplied by the square root of the variance of Y. Now at this point I will need to write out the formula for the covariance between the mathematics and the chemistry marks, and of course the covariance is the sum of the product of the mathematics and the chemistry marks divided by the total number of marks taken, subtracted by the mean of the X values and the mean of the Y values. Now I'll move on and find X bar and Y bar. What is X bar? X bar is the mean of the mathematics marks, which is the sum of the math marks divided by n, and the sum was given as 390 divided by 10, which gives us 35. Y, the mean of the chemistry marks, of course, is the sum of the Y values divided by n, which was given as 352, and all the marks that were written were 10, and 352 divided by 10 give us 35.2. Now we are going to move on 0.2 and not 0.5. So we are going to move on now and evaluate the covariance by substituting in the values into this formula. So we have 16,344 divided by 10 minus the product of those means that was obtained. And when you do the math here, you are going to have the covariance to be 261.6. So that is the value of the covariance between the mathematics and the chemistry marks. Now we are going to proceed and evaluate the variance of the mathematics marks and the variance of the chemistry marks. And the variance of the mathematics marks is given by this formula: the sum of the X squared divided by n minus X bar squared. And plugging in the values and evaluating, we have 371.4 to be the variance of the mathematics marks. Now let's move on and evaluate the variance of the chemistry marks by applying the same formula and plugging in the values. We are going to be having 229.56. So all what is left to do is to take these values and plug them into the formula for the product moment correlation coefficient. And if we plug in those values and we evaluate with our calculators, we are going to have R to be 0.894 to 3 decimal places. I hope you have understood, but if you do have a problem or a complaint, then you can write it as a comment when I finally send this video to the forum. Alright, we are through with the first part of the question. Now the second part of the question was to calculate the Spearman's coefficient of rank correlation. So to do that, we have to rank the values obtained in mathematics and also rank the values obtained in chemistry, because we need to find the difference between their rankings, and then we square it and move forward now to evaluate the Spearman's coefficient of rank correlation. Now I'll start by ranking the marks obtained in mathematics. So and I realize that the highest mark, of course, is 75, followed by 60, 55, 47. In fact, the mathematics marks was already arranged in ascending order, so I'll just rank it from 10 right down to 1. So that's why I have 75, the ranking is 1, then 2, then 3, then 4, right down to 10. Now for the chemistry marks, I'm going to rank them as well, and when I'm ranking, I'll realize that there is a tie mark, that 2 students or 2 candidates scoring a 40. And remember, when there's a tie mark, I am going to find the average between their rankings, and I will give the same value to both numbers. So I'm going to move on now, and I will see that the highest mark is 66, that takes rank number 1, then 53, rank number 2, then I have 2 40s, that is the third and the fourth position, and 3 plus 4, 7, divided by 2 is 3.5, so I will give the same values to both marks, that is the 3.5 position to both of them. Then I skip number 4 and I go to number 5, number 6, number 7, number 8, number 9, and the last value is number 10. Now I need to find the difference between their rankings by subtracting the smaller value from the bigger one, and I'll call that row D. So D is obtained. Let me subtract their rankings. 10 minus 10, 0, 9 minus 9, 0, 8 minus 7, 1, 8 minus 7, 1, 6 minus 5, 1, 6 minus 5, 1, 4 minus 3.5, 0.5, and 3.5 minus 3, 0.5, 2 minus 1, 1, 1 minus 2, 1. Then finally, I have to square this difference, and when I square each of these values, this is what I obtain. Now, what is the formula for the Spearman's coefficient of rank correlation? It's given by, so I need to add the difference of the squares values. So I need to add all these values here, and if I use my calculator and I add them, I'll be having 6.5, because I have 1, 2, 3, 4, 5, 6, and 0.25 plus 0.25 gives me 0.5. So summing everything, I have 6.5. Now I'm going to use a formula for the Spearman's coefficient of rank correlation, which is RS is equals to 1 minus 6 multiplied by the sum of the square of the difference divided by n into n squared minus 1. I'll just plug in the values and then evaluate. So I'll be having 1 minus 6 into 6.5 divided by n was 10. 10 squared is 100 minus 199 multiplied by 10. Evaluating everything gives me 0.961 to 3 decimal places. And if you were asked to find it or to leave your answers to 2 decimal places as in the question, you are going to be having 0.96 to 2 decimal places. So I hope you've understood how to obtain the Spearman's coefficient of rank correlation. Now, we were asked also to interpret these values for the sake of the data. So I would say both coefficients have a strong positive correlation between the chemistry and the mathematics marks, as we see that their values are both above 0.8, so that is a strong positive correlation, but RS is less reliable. So the Spearman's coefficient of rank correlation is of course less reliable than the product moment correlation coefficient. The reason is because the Spearman's coefficient of rank correlation only deals with the rankings between the values. The actual values have not been used to obtain the value, but the product moment correlation coefficient actually uses the value to obtain the covariance, the variance, and then evaluating to have that value. So for that reason, the product moment correlation coefficient is more reliable than the Spearman's coefficient of rank correlation, because of course it uses the actual values themselves. I hope you have understood, And now we are going to move on and find the regression line of mathematics on chemistry. So how do we find the least square regression line of mathematics on chemistry? That is x on y. It's given by the formula x minus x bar is equals to the covariance between the two max divided by the variance of y into y minus y bar. And all of these values was obtained in the first part of the question. I just need to plug in the values and evaluate. So I'll be having x minus, of course, the mean of the x value was 39, is equals to the covariance 261.6 divided by the variance of y 229.56 into y minus y bar. Then I will divide this quantity and I'll be having x minus 39 is equals to 1.1396 into y minus 35.2. I'll just have to take this value and then multiply it into the bracket or distribute it. So I'll be having x minus 39 is equals to, when I distribute, this multiplies with 35.2 and gives me 40.1129. Then all I'm left to do is to add 39 to both sides, or negative 39 crosses over the equal sign and becomes positive. So I'll have then x to be 1.140y minus 1.113 is the least square regression line for the mathematics on the chemistry marks. So this is the least square regression line. And also I was told that let me estimate the mathematics marks given that the chemistry marks was 34. So the chemistry marks y is equal to 34. Let me estimate what the candidate will score in mathematics. I just need to go to the least square regression line and I substitute y with 34, and that is it. I evaluate everything, and if I give my answer to the nearest whole number, I'll be having 38 as the value that is expected to be obtained in mathematics by a candidate who scored 34 in chemistry. Alright, I hope the first part of the question is understood, but if you do have any questions, you can leave them in the comment below this video and I'll come in and answer them. Thank you for listening.